Dr. Ritwik Basusam, currently the Deputy Manager of Research and Development at Bharat Forge Limited, Pune. Dr. Basu earned his PhD in Metallurgical Engineering and Material Science from IIT Bombay. With a rich academic and professional background, he has held positions at prestigious institutions including Bharatiya Skill Development University and Manipal University. Dr. Basu's research expertise covers a wide range of areas, including characterization, nanomaterials, and metallurgy, making him a prominent figure in the field. His extensive experience includes being a visiting doctoral student under the UK India Education and Research Initiative at Imperial College London. We are truly honored to have him as a keynote speaker today. Please join me in welcoming Dr. Vipin Bhaskar, very Dr. Bhaskar.
Institutions, and I thought when Dr. Das contacted me, I told him this would be an appropriate topic that I would be happy to deliver a lecture on. So I have been introduced, but still I'd like to once again take you through my bio sketch. So after having done my PhD from IIT Bombay back in 2012, I went to UK as a visiting doctoral student, more like a postdoc. Spent a short stint at Imperial College London. Following that, I was working in UK in an industry with their R&D as an application scientist. And then I decided to take on my second postdoc in Canada at University of Saskatchewan. And following that, I have been in academic position in various capacities at Manipal University, as well as an Indo-Swiss Skill University that came up back in 2018 under the Skill India mission. But then I'm here with Bharat Forge, with the R&D team for the last 3.5 years, a little more than that. So my research is all centered around studying the microstructure process property relationship. So what do you mean by microstructure process relationship? Can anyone answer? I mean, I'm asking from the students. So okay, I'll tell you. So this is a very key area of research in any of the domain of material science. It does not is confined to metallurgy, but people from all spectrum of material science, be it ceramics, polymers, thin films, they all are working in that end of structure property processing correlationship or relationship. So typically for metallurgists, the structure that we are referring here to are microstructures. For people who are into thin film fabrication or maybe polymeric component fabrication, they are more interested in molecular structure. Some may be interested in atomistic structure. So the structure thing is kept wide open. Okay. So we metallurgists talk mostly about microstructures. So the idea is how you can fine-tune the microstructure or tailor the microstructure by choosing the appropriate processing route. The reason being, having the right microstructure can enable you to achieve the desired property. So it's a try. But in Bharat Forge, alongside with my core research in the microstructure property relationship, I am into many other activities. My goalpost has changed from traditional microstructure research to more on the quality aspect of metallurgical engineering. That is more in demand in industry. Okay, so it's again metallurgy, but we are not drilling every time down to the microstructure level. We are talking about microstructure holistically, but that is more aimed towards directing the quality of the material. Am I making sense? Okay. So we'll come to know what do I mean by quality. So quality has
Sir, no
endless
audio.
folds. So if you can work on having the right microstructure, if you have the right microstructure recipe, and the recipe for that is processing. If you have your processing in line, in the right place, you can have the microstructure, the desired microstructure that would result to the desired outcome. But always relying on this framework of research, it often becomes challenging to really attain the quality. Just having the microstructure process understanding is good, but what else can you build on that? So there where I would say you have to adopt certain strategies might look a little different from the traditional metallurgy research, which are aimed more towards enhancing the quality improvement, or I would say process improvement. And these strategies are more data centric. Getting my point? So data centric strategies help you in drawing some statistical inferences which are not otherwise possible using the conventional research of microstructure process property relationship. So you kind of gel other aspects of the studies alongside your regular research. So that is why I felt the need to actually draw statistical inferences, not just rely on my traditional metallurgical research or microstructure research. And nearly 5 years back, while at Manipal University, when I was a faculty there, I started growing my interest in the field of analytics, or what I call as predictive analytics, or more commercially used term is data science techniques. So how you can integrate data science or predictive analytics in
Metallurgical quality control is what I'm doing right now. Makes sense? So, yes, you can call me a metallurgist. I'm a data scientist too. And
so this particular topic that I'm going to introduce you to here, okay. So this topic may sound a bit technical at the first, but then this is something which we encounter in our day-to-day life, sometimes out of realization. And this is what I call as design of experiment. So today's course is specifically oriented and structured to design of experiments, and I'll show you some nice techniques, AI analytics, how it integrates with the DOE. That is why it falls under the bigger realm of ML. Okay. Now, I'll begin with a short story from our childhood. So our mothers, like every other mothers, had an incredible knack for cooking the best recipe, the best delicious meals for us, which we are all fond of. Okay, so if you remember, they did not follow any particular recipe book or scientific methods. Rather, they used their own intuitions and experience to achieve perfection in their recipe. Okay, so what did they do? They possibly played around with the composition. We don't say composition, but the amounts of the different ingredients required. They changed the cooking time, they tweaked the temperature. This how they kept doing years over years, and finally they were able to achieve a stage where they could optimize the conditions, optimize the cooking condition, the cooking temperature, the cooking time, the ingredients, and that is how they achieve the perfection. Am I right? So one thing I must ask you, are all here comfortable with Hindi? Okay, because I have a habit of sometimes bringing in Hindi in between.
Some South Indian people are also here, sir.
So that is why I asked. So I'll keep that in mind. So the
50% are South
deliverable would be in English, 90% deliverable would be in English, but of course I might sometimes use, it's not that I'm comfortable because I deliver seminar abroad, there I'm strictly maintaining English. So no problem. So all I meant to ask you here is, you must have seen any newly married woman who takes on household activities must not be very perfectionist in cooking in the initial years, but gradually 10 years down the line they become good cook. Okay, so how does that happen? Because over the years they have sensed something, okay, something like a sixth sense that works at the back of the mind. Okay, so gradually and gradually they try to optimize the conditions and they have made a perfection. So this is why we often say experience also matters. Okay, the first time when you learn driving, possibly you must have realized if you just divert your attention here and there, you might end up with an accident. So you had a low confidence. But gradually, a time after 10 years, you feel that you are so confident that you can even talk to your friends or take a call while driving or divert your attention to something else and still confidently drive. So you have gained that confidence out of experience. So what is that in the back of the mind going? You have optimized certain conditions based on which your confidence has grown up. So these optimizations are not otherwise documented. Getting my point? So your mother making the recipe more towards perfection is an approach of DOE or design of experiment. She may not be knowing, but that is how the DOE process grows. So the basic foundation of the DOE is to strategize experiments using some statistical inferences. So what strategy you must adopt to take on an experiment is the foundational concept of DOE. So imagine yourself baking a cake. You are a cake baker and you want to manufacture or produce the best cake. So you know what are the factors that affect the cake quality. So the amount of sugar, amount of flour, amount of eggs, or you say the baking temperature, baking time. These are the essential factors that impacts the quality of the cake that you are making. But you have no clue to what amount you must add these ingredients, to what temperature you should bake. You only know that these are the factors that depends the cake quality or that impacts the cake quality, right? Now one way is you keep be trial and error. You take several attempts, keep doing one after the other. So if you rely solely on guesswork, possibly you would end up once or 1 out of 100 cake to be made in an exact perfect way, the desired quality. But then the question arises, can you repeat the same experiment over and over again? So we can't. Your mother could have, but industries do not have that time. So, because time costs money. So if you keep wasting your time, if you dedicate your time in conducting an experiment for the entire year, it's a big loss to the industry. So there has to be some strategy which is well documented. Okay, so design of experiment provides those avenues. What strategies? How do you attain those strategies? So we'll get to see all these things. Now the crude form of DOE is optimizing your process parameters. Okay, now let me tell you, many of the things which actually originated in manufacturing sectors can also apply to other service sectors. I'll tell you what it actually means. Because I have been in this field of data science for a fairly long time, and I'm not quite restrained with metallurgical or engineering data. I'm more open to any kind of data. You come up with e-commerce data, I'll be happy to build algorithm for that. Banking and finance, I'm okay with that. So because I have worked in various data science projects in the manufacturing domain, I know the criticalities. Okay, so I'll give you an interesting example. How many of you, by the way, are familiar with data science algorithms? You have a course, I'm asking for the undergraduates. Okay, no problem. So in manufacturing engineering, especially in quality control, we are concerned with something called as the defect. Okay, so in manufacturing, defect is a physical quantity, a physical thing, like a crack in a shaft is a physical thing, a physical defect which you can visually see. Or it could be microstructural defect, porosity, inclusions, these are also defects. So these defects are quite measurable. But the thing is, if you are not controlling the defects, your chances of failure could go high. So at the quality control end, you have a high chance of your products getting rejected because of failure. So a defect leads to failure. Is it making sense? Now I'll give you an interesting example from banking and finance. So I recently worked, nearly a year back, I was working on a banking finance project more related to fraud analytics. I could see there are some parallels. I'll tell you what parallels are these. So in manufacturing industry, what we call as defects, in banking sector, it is called as fraud. So in manufacturing, what defects lead to failure, in banking finance, the fraud leads to disaster. So have you heard of disaster management? These people in finance, they often talk about. So the algorithms that the AI algorithms that I can use for defect prediction can also be translated into fraud detection. Makes sense? So many a times, various problems of one domain can be translated into other domains. So defects in, we don't say defects, the term defect in finance, they eventually all result to some kind of discrepancy or frauds. So the terms are equivalent. Okay, getting my point. So now coming back to our discussion on this design of experiments. So for conducting design of experiments, what you need is data. So data is the backbone of design of experiment or any other similar methodologies that you will come to see. It's not just the DOE alone, but DOE comes as a complete suite or a package. Okay. So the most crude way of doing a design of experiment is to optimize the condition. So why is data needed? To give an example, you are trying to optimize the cake baking condition, the ingredients of the cake, the baking time and temperature, everything. How do you come to that decision making point, which is my optimized value, if you have not documented or recorded that? So keeping a record is nothing but maintaining a data. So every experiment that you have performed is recorded or documented, and that forms a data. So data is not just a single unit number, it is a complete set of observation taken across all the factors. To give you an example, let me know if my voice is audible. So, okay. So, if you have a single piece numeric value, hello? No, but let me understand if my voice is audible, people stand, okay? So a single piece numeric value is not a data, it is called a singular data point. But what is a data? Data is nothing but a set of observations taken across various
factors. So observation, here I am referring to rows. So typically in an Excel sheet, when you open an Excel, what do you see? Many rows and then you have columns. Okay. So what are these columns? The columns are the different factors. To give you an example, the quality of surface finish when doing machining, using a lathe machine for instance, depends on the speed, the RPM at which you rotate the chuck, okay, or the workpiece. The tool fit, the depth of cut. Are you familiar with this terms? Okay, so they all impact on the quality of surface finish of your product. So all these factors are called as the variables or independent factors that impacts the output. And what is the output here? The surface finish. Okay, so when you plot this or when you map it onto an Excel sheet, what typically you see in an Excel sheet, you will have many columns. And what are these columns? These columns refer to these independent variables, depth of cut, speed, flow of cutting fluid, and so on. And the rows are nothing but observation taken under at each state of the condition. Make sense? Getting my point? So that entire set of values is what we call as my metadata. Have you heard of this term before? Metadata. So data is essentially a metadata, significantly voluminous.
There is a break of 15 minutes. After that, we will continue. All the participants are requested to join the team